طيب بسم الله الرحمن الرحيم. Now we'll start doing some questions from the book, including suggested problems for sure. Yeah, let me do now. In this group of questions, I'll choose 3 questions. Problems 1 through 16, homogeneous, second order, linear differential two functions are given. What they want, verify their solutions. Then find the particular solution satisfying the initial condition. Okay. So I need to prove that y1 and y2 are solutions to the differential equation. This is my first step. Second step, find the particular solution with this initial condition. Okay. So now y1 equal e to the power x. I need y double prime. So I have y1 prime e to the power x, y1 double prime e to the power x. Now satisfy the equation, just substitute. I have left-hand side y1 double prime minus y1. That would be e to the power x minus e to the power x, which is 0, which is the right-hand side. So y1 is a solution. Now for y2 is e minus x, y2 prime minus e minus x, y2 double prime will be e minus x. The same, left-hand side, y2 double prime minus y2, what do you got? E minus x minus e minus x, which is 0, which is the right-hand side. So for sure, y1 and y2 are solutions of this differential equation. Okay. Now we need to use the condition for this solution, C1 y1 plus C2 y2, which is C1 e to the power x plus C2 e minus x. I need y prime, since I have a condition for y prime. So I have C1 e to the power x minus C2 e minus x. Okay, y at 0 equals 0. So I have what? C1 plus C2 e to the power 0 is 1, is equal to 0. Y prime at 0 equals 5. So you have what? C1 minus C2 equals 5. Add them. 2C1 equal 5. So C1 equal 5 over 2. Okay. So it will be C2. From this, C2 equal minus C1, which is minus 5 over 2. So it will be my solution. Y will be 5 over 2 e to the power x minus 5 over 2 is minus x is. Okay. Another group of questions. Now I have, this is y1, this is y2. I need to show they are solutions. This is part 1. Huh? Yeah, let me say this is part 1. This is part 2. So we'll do part 1. y1 e to the power 5x. What will be y1 prime? 5 e to the power 5x. y1 double prime, 25 e to the power 5x. Okay, left-hand side, y1 double prime minus 10 y1 prime plus 25 y1. That will be 25 a5x minus 10 times 5, which is minus 50 a5x plus 25 e to the power 5x. So 25 plus 25, 50 minus 50. That is 0, which is the right-hand side. Okay, y2 is what? X e to the power 5x. So it will be y2 prime. I need product rule. So you have e to the power 5x plus 5x e to the power 5x. What will be y2 double prime? 5 e to the power 5x plus 5 e to the power 5x plus 25x e to the power 5x. Okay, now we'll check left-hand side. y2 double prime minus 10 y2 prime plus 25 y2. Now I need to plug these functions. Yeah, I have 5 plus 5, that will be 10. Let me put it here. A5x plus 25x e to the power 5x. Now minus 10 times this. So I have minus 10 e to the power 5x minus 50 x e to the power 5x. Then plus 25 times this one plus 25x e to the power 5x. This with this cancelled and this cancelled. So I have 0, which is the right hand side. So that means y1 and y2 are solutions for this equation. Okay. Now we need to find the initial conditions. This is part 2. I have y equal c1 e to the power 5x plus c2 x e to the power 5x. Okay. Now I need to find the conditions. Yeah. Y at 0. No, I need y prime. Yeah. Because I have a condition for y prime. Let me find y prime. That will be 5c1 e to the power 5x plus 5c2 x e to the power 5x. Yeah. Plus c2 e to the power 5x. Okay. Y at 0 equals 3. That implies what? C1 equals 3, but this will be 0. Y prime at 0 equals 13. So I have what? I have 5c1 plus c2 equals 13. Five c1 plus c2 equals 13. Okay. So I plug this here. I have 15 plus c2 equals 13. So c2 equals minus 2. So it will be my solution. Y will be 3 e to the power 5x minus 2x e to the power 5x. Okay. Next one. Same thing. First, I need to prove that these are solutions satisfying this equation. Okay. So I have y1 equal x, y1 prime equal 1, y1 double prime equal 0. Left hand side, x squared y1 double prime minus x y1 prime plus y1. X squared times 0, this is 0, minus x times 1 plus x, that is 0, which is the right hand side. Now for y2, I need to be careful. X then x, what will be y2 double y2 prime? Product of two functions, I have 1 plus nx. What is y2 double prime? 1 over x. Okay. Now left hand side, x squared y2 double prime minus x y1 prime y2 prime plus y2. Okay, I have 2 okay, show. Yeah. Okay, so x squared times this, I have x. X times this, I have minus x, then x, plus x, then x. And that is equal to 0, which is the right hand side. So y1 and y2 are solutions of this equation. Okay, that's part 1. Part 2, I have y, I'm dealing with y equals c1 x plus c2 x ln x. What will be y prime? C1. That give me what? C2. The x derivative is 1 over x times x, that is 1. Plus C2 ln x. Okay. Conditions. I have y at 1 equals 7. So I have what? C1 ln 1 is 0 خلاص equals 7. Now y prime at 1 equal 2. I have what? C1 plus C2 ln 1 is 0 equals to 2. Plug it here. So C2 equal to minus 7, which is minus 5. So it will be my answer. Solution y equals C1. C1 is what? 7. X and C2 minus 5. X ln X. That will be my answer. Okay, this is what I will do. I will try to choose some problems in each group of questions. Okay, the following 3 problems illustrate the fact that the superposition principle does not generally hold for nonlinear equation. What is the superposition principle? If I have y1 and y2 are solutions, then the linear combination is also a solution. But this is true if I have what? Linear homogeneous differential equation. Okay, now let me do 17. What he want to prove? I have this is the equation, y prime plus y squared equals 0. This is my solution. He wanted me to show that is a solution. Yeah, easily. Y prime will be what? Minus x minus 2. Plug it here, left hand side. Y prime plus y squared. That will be minus 1 over x squared plus 1 over x squared, which is 0, which is the right hand side. So y is a solution. Okay. But that if c not equal to 0 and c not equal to 1, then y equals cx. Okay, check. Y equal c over x is not a solution. If c not equal to 0 and c not equal to 1. Let me find y prime. Y prime will be what? Minus c over x squared. Now let me check y prime plus y squared. That will be what? Minus c over x squared plus c squared over x squared. And this will be c squared minus c over x squared. That will equal to 0 only if c squared minus c equals 0, i.e. c equals 0 or c equals 1. So y equal c over x is not a solution if c not equal to 0 or c not equal to 1. Because it's solution only if c equals 0, c equals 1. That does not contradict the superposition principle, because superposition principle is for linear. This is not linear equation because of y squared, not linear. Now let me do 18, same idea. You want me to show this is a solution. Very clear, this is not linear. Okay, I have y equal x cubed. What will be y prime? 3x squared. Plug it here, left hand side. I have y. I need y double prime, sorry. Y double prime will be 6x. Oops. So I have y double prime. That will be what? X cubed times 6x. That will be 6x to the power 4, which is the right hand side. So it's a solution. So if c squared not equal to 1, then cx cubed is not a solution. Show y equal cx cubed is not a solution if c square not equal to. Okay, let me check this. Y prime will be 3cs x squared. Y double prime will be 6cx. Okay, left hand side, I have what? Y double prime will be what now? Cx cubed. This one 6cx, which is what? Yeah, 6c squared x to the power 4. And we want to prove this is equal 6x to the power 4. And that is true if c squared is equal to 1 only. So that means if c squared not equal to 1, then y equal cx cubed is not a solution. Okay. I think I need more space for the next one. Okay. The last one, by the way, this is the one in the suggested problems. Y equal 1, y squared equals square root 2. Our solution of this, I have y double prime. It's 19. Is it y double prime plus y prime squared is equal to 0? Show that I have y1 equal 1. Our solutions. This is what I want to prove. So y1 equal 1. So y1 prime equals 0. y1 double prime equals 0. Very clear, left hand side, 1 times 0 plus 0 squared, which is 0, which is the right hand side. So we have no problem. y2 x to the power half. What is y2 prime? Half x minus half. What is y2 double prime? That will be minus 1 over 4 x to the power minus 3 over 2. Plug it now. Left hand side, y2 double prime plus y2 prime square. That equal to what? y2 x to the power half. This is minus 1 over 4 x to the power minus 3 over 2 plus y2 prime. That will be plus 1 over 4 x to the power minus 1. Minus half to the power 2. That make it minus 1. So that is what? Minus 1 over 4 x to the power minus 1 plus 1 over 4 x to the power minus 1, which is 0, which is the right hand side. So y1 and y2 are solutions. This is not linear. So the claim now show y equal 1 is not a solution. So we cannot add only these two solutions. So superposition principle will not be, will not hold. And that's true. I mean, because this condition of linear differential equation is not does not meet. Okay. So I'll check y prime will be what? The same thing, half x minus half, and y double prime will be minus 1 over 4 x minus 3 over 2. Okay, left hand side, y double prime plus y prime squared, that will be equal to what? Y, which is 1 plus the square root of x. Let me make it x to the power half. Make it easier. Times half x minus, no, I need y double prime times minus 1 over 4 x to the power minus 3 over 2 plus this square, which is 1 over 4 x to the power minus 1 equals. This will be minus 1 over 4, x to the power minus 3 over 2, minus 1 over 4, x to the power minus 1. Half minus 3 over 2 is minus 2 over 2, which is minus 1. Plus 1 over 4, x is minus 1. This is cancelled, but I still have this. And this is not equal to 0. So, is not the solution. As I said, in all of these three problems, we cannot apply the superposition principle. Why? Because the equations are not linear. All of these equations not linear. Okay, that's mainly the idea of this question. Okay, determine that the pairs of functions are independent or dependent. Okay. Let me do these problems. 20. Okay. Yeah, 20 is very clear. I will do C1 f of x plus C2 g of x. I know this is equals to 1. So I have C1 times pi plus C2 equal to 0. This is equal to 1. So let me choose this to be minus pi, and this is 1. So I have pi minus pi is equal to 0. So I linearly dependent. Okay. (21) f of x equal x cubed and g of x squared absolute value of x. Yeah. How to check if you have two functions? How to check they are linearly dependent or independent? Can I write one as a linear combination with the other one? No. Is there a C? Is f of x a linear combination of g of x or otherwise? No. No. Why? Because um, x cubed equal because x squared, let me do that. X squared absolute value of x is what? Is x cubed if x is positive and minus x cubed if x is negative. So we cannot write f constant times u of x. So x cubed and x squared are linearly independent. Okay, 24. As we did before, I'll try to choose some problems. I know cosine 2x is what? Is 2 cosine square minus 1. So very clear, I can write C1 f of x plus C2 g of x, make it equal to 0. How? Let me write C1 cosine 2x plus C2 1 minus 2 cosine square x equal to 0. Now, I needed to know this is what? 2 cosine square x minus 1. So if I choose this is 1, and I add it with this, I choose this is also 1, I'm getting 0. So they are linearly dependent. 25. Yes, they are linearly independent, because if I divide this function, they are not linear, they are not a constant multiple of each other, because if I divide this by this, I'm getting what? Tan x, not constant, not a constant. Yeah, 26. Yeah, is there a way to write C1? Is there a way to write one as a multiple of the other one? Is that possible? Check. I have 2 cosine x plus 3 sine x will be equal k 3 cosine x minus 2 sine x. Very clear by looking. This is impossible. Multiply by a constant and get this. But just for calculation, is there possible to find a k satisfying this, which is very clear this is impossible? Let x equal 0. See what will happen. I have 2 sine 0 is 0 equal k times 3. So 2 equal 3k. 2 equal 3k. Cosine 0 is 0k. Put x equal pi over 2. Since this should be true for any x. So I'm saying, I'm trying to get a contradiction. You know, this is impossible. That this equal a constant times the other one. Put x equal pi over 2. This is 0. I have 3 equal what? Minus 2k. So from here, I'm getting k equal 2 over 3. But from here, I'm getting k equal minus 3 over 2. Contradiction. So they are linearly dependent. Impossible to write a function in terms of as a constant multiple. Okay, problems 29 to and 30. So try to do these two. Okay. Show that y1 and two different solutions of this equation, both satisfying the initial condition. He's making these questions about the existence and uniqueness. Here, where we say what? If I wrote the function, I wrote the equation in this form. Let me just remind you. If B and Q are continuous, then the initial value problem they have y at A equal A0 and y prime at A equal B0 has a unique solution. That's the existence and uniqueness theory. Okay. So, but now he's saying it's not the Wronskian. It's okay. Yeah. Show that y1 and y2 are two different solutions of this. What's this like the initial conditions? Yeah. First 29, I need to check and y1 is a solution of this equation. Yeah, I can check y1 prime and y1 double prime. Substitute there, left hand side. I have what? 2x squared minus 4x times 2x plus 6x squared. So it will be 2x squared minus 8x squared plus 6x squared, which is 0, which is the right hand side. So it's a solution. Now we need to check also x cubed. So I have y2 prime 3x squared, y2 double prime will be 6x. Substitute there. I have x squared times 6x minus 4x 3x squared plus 6x cubed. That equal what? 6x cubed minus 12x cubed plus 6x cubed, which is 0, which is the right hand side. So y1 are solutions. Not only that, this equation, and also I can check the condition. Y at 0, y1 at 0 will be what? 0, correct? Y prime at 1 at 0 will also 0. Y2 at 0 equals 0. Y2 prime at 0 is equal to 0. Very clear. So I have for the initial value problem, this initial value problem, which is a differential equation with the conditions. This has two different solutions. Does not have a unique solution. Why this is true? Why this is, does not contradict this existence and uniqueness theorem? Very simple. Because if I check, now if I write this in standard form, I have y double prime minus 4 over x y prime plus 6 over x squared equals 0. And this is not continuous at x equals 0. But my initial condition depends on 0. Because of that, this is has two different, yeah, I cannot apply. So this theorem, we cannot apply the theorem. Yeah, continuous in an interval containing a. Okay, which is 0 in this case. There is no way I find the function. I'd find the interval where these two functions continuous. Yeah, 30. Show that these are linearly independent solutions on the real line. Verify that this is exactly 0. Why do these facts not contradict theorem 3? What is the equation? Yeah, I need a space. I think I need a space. Okay, what's the equation? X squared y double prime minus 3xy prime plus 3y equals 0. Okay, I want to show in y1, y2, y1, which is what? X cubed and y2 absolute value of x cubed are linearly independent solutions. Yeah. Yeah, for y1, how to show it? Say it's a solution. This is easy. y1 prime equal 3x square, and y1 double prime equal 6x. Left hand side will be what? X square y double prime minus 3x y prime, or y1 plus 3y1. That will be equal to what? 6x cubed minus 9. Yeah, minus 9x cubed plus 3x cubed, which is 0, which is the right hand side. How to do this one? Now y2, I can rewrite it as what? X cubed if x is minus x cubed if x is negative, and x cubed if x is positive. And y2 prime will be what? Minus 3x squared if x is negative, and 3x squared if x is positive. Yeah, they are also continuous at x equals 0. Satisfying at 0 bottom. Okay. So now I work it for x positive, for x negative. I check the equation. X squared y2 double prime minus 3x y2 prime plus 3y2. That will be what? X is negative. Yeah, what will be y2 double prime? Sorry. Y2 double prime will be what? Minus 6x if x is negative. 6x if x is positive. And I can put the equality because still they satisfy both. At x equals 0. Okay. So I plug the numbers for x negative. I have what? X squared y2 prime, which is minus 6x minus 3x y2 double prime minus 3x squared plus 3 minus x cubed. That will be what? Minus 6x cubed plus 9x cubed minus 3x cubed, which is 0. For x positive, I think it will be x cubed, so we did it here. Similar to this. So it's true. So both are solutions. Both are solutions. Okay. Now, what will be the Wronskian to show they are linearly independent? What was the linearly independent? Yeah, they are linearly independent. Why? Y1. Oops. Y1 and Y2 are linearly independent because I cannot write x cubed equals c absolute value of x cubed. This is impossible. Impossible. Like what we did before, like what we did when actually we did it here. Yeah, we explain it here. So they are linearly independent. Okay, now we need to find what? Verify that the Wronskian is identically 0. Okay, I need to find the Wronskian of these two. This is part B, this is part A. Wronskian of y1, y2 will be what? Yeah, I'll take it cases. So for x negative, I have what? X cubed. And this is what? And the other one minus x cubed. So I have 3x squared minus 3x squared. That give me what? That give me 0. Yeah. and give me 0. Okay, yeah, very clear. Minus 3x. Yeah, let me do it in details. Minus 3x to the power 5 plus 3x to the power 5, which is 0. Now for x positive, what I have? X cubed and x cubed. Yeah, very clear. This is 0. Now, at x equals 0, what will happen? At x equals 0, I know from here y2 prime at 0 is 0. So I have what? 0, 0, 0, 0, which is 0. So that means the Wronskian identically 0. Yeah, at x equals 0, this one will be 0. Since y double prime, yeah, let me do it this way. At x equals 0, I have y1 prime, y2 prime. What is y1 at 0? y1 at 0, x cubed, it will be 0. Derivative of y1, 3x squared, that will be 0. y2 at 0 is 0. y2 prime at 0 from here, it's 0. So this is 0. So that will be 0. So I have Wronskian is identically 0. Why this does not contradict the theorem? Because these are not linear. Huh? These are not linear. I mean, I have the same problem. This one, if I divide, I have y double prime minus 3 over x y prime plus 3, oops, yeah, plus 3 over x squared y. From this and this, not continuous at x equal 0. So we cannot apply the theorem. Okay. So in the theorem, I need the functions to be continuous at A. Okay. Now just next group of questions, which is we need to solve these differential equations. Okay. First one, 39, which is easily find the auxiliary equation. We have 4r squared plus 4r plus 1 equals 0. So I have 2r plus 1 squared equals 0. So I have r equal minus half. What will be y? General solution. C1 is minus half x plus C2x is minus half x. Okay. 41. Auxiliary equation. 6r squared minus 7r minus 20 equals 0. I want to factor it. It's 41. Yeah. Let me try to do factoring. I have 3r, 2r. Yeah, 20. I need what? I have minus 7. So, yeah, I think I need minus 5. So this will be minus 15 plus 4. 8 minus 15 is minus 7. Good. This is minus 20. Or you can do it by the quadratic formula. So r equal minus 4 over 3 or r equal 5 over 2. So it will be my general solution. So general solution y equals C1 is minus 4 over 3x plus C2 e to the power 5 over 2x. If you're gonna do it this way, do it using the quadratic formula. X equal minus b plus or minus. You remember this. You'll get the sense. Okay, now do this group of problems. 36. What is the auxiliary equation? 2r squared plus 3r. Can take r. I have 2r plus 3 equals 0. Minus 3 over 2. So it will be my general solution. Y equals C1 e to the power 0, which is 1, e to the power minus 3 over 2x. 38. Auxiliary equation or characteristic equation. 6r squared plus 5r minus 6 equals 0. Yeah. Can I factor it? Let me try. We have what? Let me do it quadratic formula. Since I did, yeah. X will be what? Minus b plus or minus square root b squared 25 minus 4ac. 4 times 36. What is this? Yeah, let me do it. 36 times 4. 4 to 144 with a plus sign over 12. That will be minus 5 plus square root 169. That will be 13 over 12. So I have R, X, R. So I have R1 minus 5 minus 13 over 12. That is minus 18 over 12, which is what's minus 3 over 2. And R2 minus 5 plus 13 over 12, which is 8 over 12, which is 2 over 3. Okay, so what will be the general solution? Y equal C1 is minus 3 over 2x plus C2 A2 over 3x. Yes. Last one, 40. What is the auxiliary equation? Oops. 4r squared minus 12r plus 9, which is what? 2r minus 3r squared. Yeah. 4r squared minus 3 times 2 times 2, which is minus 12r plus 9. Yes. So r is what? 3 over 2 and 3 over 2. General solution, y equals c1 e to the power 3 over 2x plus c2x e to the power 3 over 2x. Yeah, I think this will be the answer. Correct. Okay. I think we did good number of questions. Now we finish by this group of questions. Actually, I put them all, no problem, which is the other way. Now, he wants us to find the differential equation. He gave us the homogeneous, the general solution, and he wants us to find the differential equation. So he wants us to revise this process. And instead of auxiliary equation to the root, instead of finding the auxiliary equation roots, then the solution, usually we're doing it like this. I have the equation. Then I will find the auxiliary equation. Then I find the roots. Then I find the general solution. Instead of going this way, you want me to do it this way. And that's what I want. Okay, let me do 43, since an easy one. So this is the general solution. which I can write as C1 is 0x. So for sure the roots are what? 0 and minus 10. So it will be the auxiliary equation r minus 0, r minus 10, which is r plus 10, which is r squared plus 10r. So it will be the differential equation y double prime plus 10 y prime equals 0. That's what I will do for the rest. 44 roots, very clear, 6 minus 6. Auxiliary equation r minus 6, r plus 6 equals 0. So I have r squared minus 36 equals 0. So it will be the differential equation y double prime minus 36y equals 0. 45. I have now this and x. That means I have the root doubled. So the roots are minus 10 and minus 10. So it will be the auxiliary equation r plus 10 square equals 0. So I have what? R square plus 20r plus 100 equals 0. Yeah. So it will be the differential equation y double prime plus 20y prime plus 100y equals 46. Roots are what? 10 and 100. 10 and 100. Okay. So it will be the auxiliary equation r minus 10 times r minus 100 equals 0. So I have what? R squared minus 10 minus 100 minus 110 r plus 1000 equals 0. Differential equation. One thousand y equals 0. Next one, 47. What are the roots? 0 and 0. Yeah. Let me write it again. We have y equals C1 is 0x plus C2x is 0x. So the roots 0, 0. Auxiliary equation r minus 0 times r minus 0, which is r squared equals 0. Differential equation y double prime equals 0. Easy one. Last one. What is it? 48. Yeah, I need to rewrite it. Y of x is what? E minus 2x C1 a square root of 3x plus C2 a minus square root of 3x. In other words, I can write it C1 a minus 2 plus the square root of 3x plus C2 a minus 2 minus the square root of 3x. Okay, that is the equation. Yes. Now, what are the roots? Be careful here. The roots are minus 2 plus the square root of 3 and minus 2 minus the square root of 3. So it will be the auxiliary equation r minus 2 plus the square root of 3 r minus 2 minus the square root of 3 equals 0. So I have what? R plus 2 minus the square root of 3 and r plus 2. Sorry, this is minus, yeah, plus the square root of 3. minus times minus, it will be plus, equal to 0. I can rewrite it. I have it x plus minus y times x plus y. So I have r plus 2 all square minus square root of 3 all square equal to 0. So I have r square plus 4r plus 4 minus 3 equals 0. So I have r square plus 4r plus 1 equal to 0. So it will be the differential equation y double prime plus 4 y prime plus y equals to 0. I think now I will stop the recording. Yeah, we'll finish now. Questions from section 5.1, including all the suggested problems. Now I will stop the recording. Thank you.